We're going to do a quick review of how to write sigma notation and also how to use the three formulas that we've learned for Chapter 9. So we're going to look at an arithmetic series example first. This was taken from one of your assignments, so it should look familiar. There are 22 rows of seats in a high school auditorium. There are 17 seats in the front row, and each of the other rows has 2 more seats than the row directly in front of it. To write this sigma notation, first of all, figure out the explicit equation, and if it's arithmetic, you could write it as a linear equation, y equals mx plus b. So to do that, we need the slope, which we can see is 2 because there's 2 more seats than the row directly behind it. We need the y-intercept though. If there are 17 seats in row 1, you would have to think how many seats would there be in row 0. So if we're adding 17 each time, we're going to work backwards to find the y-intercept, and that would mean our linear equation would be y equals 2x, again the 2 is the slope, and we would start with 15 seats if there were row 0. Now the sigma notation part, we'll write our sigma. We'll put our linear equation here, so instead of 2x plus 15, they usually use n, so I'll change it to n plus 15. And we're going to start n equals the first row, and if we want the sum of the first 5 rows, I'm going to put a 5 right here. So here's the sigma notation. Put the linear equation here, put your starting row here, then however many rows you want to go up to, and this stands for the sum of the first 5 rows. To find the sum of the first 5 rows, we can either write out each term, each row, and add them together, or we can use the sum formula for an arithmetic series, and that formula would be S sub phi, the sum of the first 5 rows, is the number of seats in the first row plus the number of seats in the 5th row times the number of rows, and here there's 5 rows. So we multiply that by 5 and we'll divide by 2. We know how many seats there are in the first row. There's 17 seats in the first row, but we need to figure out u sub 5. I'll do that work over here. U sub 5, plug in a 5 for n, so 2 times 5 plus 15. And if we calculate that, 2 times 5 is 10, 10 plus 15 is 25. There's 25 seats just in row 5. So let's plug that into our equation. So again, there are 17 seats in row 1, there's 25 in row 5, there's 5 rows we want the sum of. We'll divide by 2. And if you calculate that, you're going to get 105 seats in the first 5 rows. So there's an example using the arithmetic formula. First term plus last term times the number of terms divided by 2. Here's an example of the sigma notation. Put the linear equation here, starting with your first term and going to whatever term you're looking for. Let's take a look at what if it's an infinite geometric series. Here's an example. Let's say you had a grandfather clock, and the pendulum, the part that swings back and forth, initially swings an arc of 18 inches. After each successive swing, the length of the arc is 0.98 of the previous length. So write the sigma notation. We'll need the first term of the ratio. So the first term here is 18 inches that it swings. The ratio is 0.98. So when you write the sigma notation, we start at n equals 1. And this one we don't know how far it's going. I'll say it's going to infinity. If it keeps swinging forever. We always start with our first term, which is 18. In our parentheses, we write the 0.98. But the exponent here, if we put a 1, it's going to be 18 times 0.98. We want the 0.98 to equal 1, and so I'm going to put n minus 1 here, because 1 minus 1 is 0, and 0.98 to the 0 power is 1, and that's what I want it to equal, because I want the first term to be just 18. So in other words, when I plug in a 1 here, I want this to equal a 1, so that my first term is 18, so it's n minus 1. What is the total distance the pendulum swings? If it keeps going on and on forever, it's infinite geometric series. Let's use that formula. The sum is the first term over 1 minus the ratio. First term is 18, 1 minus 0.98, which is 0.2. And if you calculate that, it would swing a total of 900 inches. Last type of problem, what if it's not, what if it's a partial sum? So partial geometric series. Write the sigma notation. You need to find the first term in common ratio. First term is 200. Common ratio, you take any number, for example, 150, divide by the number before it. And this ratio is 0.75, and that works for each of the terms. So you could have chosen any term divided by the one before. So 0.75. All right, the sigma notation. Again, we have our starting value. We have our ratio. We're going to do it to the n minus 1 power, so that when the first term is 1, that this will be 1. And we want the partial sum for the first 10 terms, so I'm just going to go up to the 10th term here. Again, you can list them all out and add them together, or use the formula, and the sum formula will be the sum of the first 10 terms. The first term times 1 minus the ratio to the n power over 1 minus the ratio. First term here is 200. Ratio is 0.98. And n is the number of terms. We want it to the 10th power over 1 minus 0.98. So if we put that in our calculator, the sum of the first 10 terms will be 754.95. All right, so there it is, just a brief review. You can use that to help you study.